Okay, so in this video, I want to look at a new TTS system. And this is a TTS system that's getting quite a bit of attention, partly because of its interesting story that it's basically built by two undergrads who just wanted to replicate something like NotebookLM and ended up building a TTS system, which a lot of people are saying is as good as 11 Labs or OpenAI or things out there. So if we come in and look at Hacker News, we can actually see that the two creators, Toby and Jay, created this TTS system called Dia. Now, this is a 1.6 billion parameter model. They're calling themselves Nari Labs, but I think at the moment it's just the two of them. I don't think they have any funding or anything like that. But you'll see that they're able to get very good quality results. So let's take a listen to this.
Dia is an open weights text-to-dialogue model.
You get full control over scripts and voices.
Wow, amazing.
So try it now on GitHub or Hugging Face.
Now, as you can hear, the quality there is very good. And they've even got examples comparing it to 11 Labs and to the Sesame model as well. For me, really what is interesting here is that this is two guys that basically really liked the NotebookLM podcast kind of stuff. They talk about themselves as not being AI experts from the beginning, but they basically wanted to learn how to do this and build this themselves. And they've certainly done a good job. So they talk about the model that they built being heavily influenced by SoundStorm and Parakeet. So SoundStorm is a paper that came out of Google back in 2023. I remember when this came out because at the machine learning meetup that I co-organized, we actually hosted one of the people involved in this and they played us some examples at the time, and we were pretty blown away by how good it was. The other work that they talk about being heavily inspired from is this model called Parakeet. And this has a very nice write-up that explains how it's done and stuff like that. That still left them with a huge problem in here, is that their biggest challenge was how do you get compute? In fact, you can see it here. They talk about the biggest block was compute. Now, Google has a program that you can get access to compute under the form of the TPU Research Cloud grants. And that can actually get you a decent allocation of TPUs so they can use them for training models that are going to be open, etc. Now, of course, one of the challenges that they had was that to really make the best use of TPUs, you probably want to write the model in JAX. And this is literally what they did. They looked at how to do this and then went on to train the model. But then they also had to convert it back to PyTorch so that most people could actually use it. And they've gone and done this. I think this is really what they should be commended for. So if you want to try the model out, you can come to the Hugging Face spaces and try it out here. You can do either straight up text synthesis, or you can do audio voice cloning via an audio prompt kind of thing in here. They've got a whole bunch of things in here that you can set. You can see that you can generate the audio.
Open weights text-to-dialogue model. You get full control over scripts and voices.
And you can change any of the text in here to create the audio we want. What I'm going to do is jump into Colab and look at how we could play with this in code to try and reproduce the sort of NotebookLM podcast experience that they were originally going for at the start. So let's jump in and have a look at that. Okay, so installing the model is pretty simple. You can basically bring it in like this. One of the things that's been talked about on Twitter is that it's actually going to be brought to the MLX audio library, which I think that will also make it really cool for using it locally, etc. Here at the moment, I'm basically using it with a GPU, but that said, I'm only using it with a T4 GPU. So that you could use the free version of Colab to actually be able to do this. So we just install the package. After that, we basically load up the model here. And the model will take a little bit. You need to basically obviously download the weights from Hugging Face. And then you can generate text out just by basically passing in a string and doing model.generate. And you can see here, I'm just basically playing this back.
Hey, Sam, how are you? Let me tell you about Dia. It's an open weights text-to-dialogue model.
You get full control over scripts and voices.
Wow, amazing.
Try it now on GitHub or Hugging Face.
You bet I will.
Okay, so you can hear there that the voice is actually very good. Now, currently, you don't seem to be able to have a lot of control over what S1 voice will be and S2. But basically, if you start each new bit where you want a new speaker to speak, you can get it to, using this S1 and S2, you can get it to speak in the different voices. Now, sometimes one of the voices will be female, sometimes both of them will be male, don't think I've had yet where both of them are female, but you certainly can get a variety of different voices. Now, it seems to me this has got something to do with an embedding. So I may actually play with the model again and see if I can work out how to save certain voices so that you could use the different voices again. Now you can see if I run the exact same thing and put it out to a different file now.
Hey, Sam, how are you? Let me tell you about Dia. It's an open weights text to dialogue model.
You get full control over scripts and voices.
Wow, amazing.
Try.
Okay, so you can see here, this time we've got the exact same text, but we're generating and getting different voices out there. So you'll notice one of the other challenges that this model has too is that it basically tends to speed up the audio. And it does seem that the longer the text that you put in there, the more it will try to speed up that audio in there. So that's something that I've been certainly looking at different ways you can do a workaround of that. And that brings me to the idea of making the NotebookLM style podcast. So the authors mentioned that they were heavily influenced by NotebookLM and they wanted to be able to do this. So what I basically did was put together a simple prompt, and you can certainly improve this prompt. This was just put together pretty quickly, of telling it to generate something out that is going to be like this, where we've got the S1, S2, so we can see the dialogue for speaker 1, dialogue for speaker 2, etc. It's going to generate it without any prefix or any sort of suffix after that. So it won't sort of say, here is your dialogue or something like that. That's something that you can see I've got here. Do not add any introductory text, explanations, summaries, or outside of the formatted script itself. And what I'm doing is just passing in a video, a YouTube video, and getting it to basically write the sort of podcast about that video. This is the video that I made about doing audio transcription and stuff like that. So we've passed that video in. You can see the code for doing that. Obviously, I'm using the Gemini 2.5 Pro model here. The code for doing that is pretty simple. I've got a whole video up about how to do that and different tricks you can do with that, etc. And you can see that what we ended up getting out here was this script. Now, this script is pretty long. So if I go to generate this, you'll see that when I go to generate this, this turns out to be too many tokens for the model to be able to generate. And you can hear this. Like, let's listen to this.
Hey, did you see that video about using the new Gemini 2.5 Pro for audio stuff?
Oh, yeah, the one talking about transcription and understanding audio? Pretty interesting.
Totally. I've been looking for better ways to get transcripts from podcasts or meetings without having to listen to the whole thing.
Okay, so you can see that it basically cuts out at around this sort of 22, 23 second mark there. And there's lots of script left that didn't make it in there. You can also hear that it's just speeding up as it goes through this. So what I did was basically just write a little function that will go through and take our script and split it into different segments. Now, the way I've done it here is I've taken where it's gone S1, S2, S1, S2. So I actually split them into 3 pairs, but you could change this to be 2 pairs. You could change this to be longer or shorter if you want to. And actually 2 pairs may work better in regards to the speeding up issue, etc. So you can see with 3 pairs coming out, we end up with a section of 4. So now we can just go through and generate out an audio file for each of these, and then we can combine these together. So in the end, you're going to get something like this. I'm not going to play the whole thing, but you can sort of listen to it a bit.
Get transcripts from podcasts or meetings without having to listen to the whole thing.
Exactly, and Gemini 2.5 seems like a big step up. It can do transcription, diarization, figuring out who's speaking when, and even Q&A over the audio. That diarization part sounds amazing. So, what's the big deal with 2.5 Pro compared to the older models? The massive output token limit. The previous ones could only output around 8,000 tokens, which limited how much transcript you could get in one go.
Ah, okay, so how many tokens can 2.5 Pro handle?
Get 1,000 tokens out. That's huge.
Wow, what does that translate to in terms of audio length?
The video calculated it's roughly enough for a 2-hour audio file's transcript in a single output. That's a game.
Okay, so you can see that now by joining them together, we're able to go beyond the sort of 22, 23 second limit here. But we still got the issue around sort of the speed thing. Now, actually, if I did it in lots of pairs of 2, it might actually even get better than this going on. But what I thought I'd do is try out some different ways of slowing down the audio. So this is sort of the first one of using just Librosa to do this and doing a time stretch. Now, it works, but for me, the audio is pretty phased in here.
Hey, did you see the video about using the new Gemini 2.5 Pro for audio stuff? Oh yeah, the one talking about transcription and understanding audio? Pretty interesting. Totally. I've been looking for better ways to get transcripts from
Okay, you can hear that the audio there is very phased in the output. So another one that I played with that actually seems to come out better is this rubber band. And this is basically just got a better algorithm, I think, for doing the time stretch. It's still not perfect, but probably a little bit better.
Hey, did you see that video about using the new Gemini 2.5 Pro for audio stuff? Oh yeah, the one talking about transcription and understanding audio? Pretty interesting. Totally. I've been looking for better ways to get transcripts from podcasts or meetings without having to listen to the whole thing. Exactly, and Gemini 2.5 seems like a big step up. It could do
Okay, so you can hear that this one's still not perfect, but it's getting interesting. So that speed issue actually comes from the way that the model's working. It's using what's called classifier-free guidance. And perhaps the best way to actually do this is just to sort of generate really short audios, because it doesn't apply as much there, and then join them together. Anyway, from this, the idea here is that you could put something together that you could just pass in a YouTube video, and it then makes a podcast of that YouTube video. You could also, of course, do it where you pass in an academic paper and make a podcast, all the sorts of things that people are doing with the kind of NotebookLM style of things. That now in the code on their demo, you can also see in here, they've got some speed factors and stuff like that. That said, experimenting around with this didn't seem to make it hugely better there. That's something that is definitely worth trying as well. Anyway, I'll leave it for this video there. If you want to, you can also do voice cloning with this. If people are really interested, perhaps I'll make a video around the voice cloning if people want to do that. And like I said, hopefully this is going to be up in the MLX audio library in the next few days or week or something. I think they're planning to put it up there in the next version. So that will make it sort of more accessible for running it locally if you've got a Mac but you don't have access to a GPU, etc. So overall, this is definitely a nice TTS system. It's probably not fast enough to run real time if you wanted to use for doing real time sort of stuff. But I think it was designed more to do things like the NotebookLM podcasts and do sort of generation out of stuff. And it does create some really nice quality for that kind of thing. So check it out, have a play with the code. As always, I'll put the notebook in the description below where you can try this out. You can also try out the Hugging Face version and stuff like that to play with it. Anyway, as always, I'd love to hear what you think in the comments. Let me know how you think the quality compares to the things that we've looked at before, like Kokoro and some of the other TTS systems that are out there, and where you could see yourself using it. And I will talk to you in the next video. Bye for now.